today we're going to solve sample problems on column-based plate. Okay, so let me share my screen. Okay, so for the first problem on column-based plate, so sample problem number 9 rather. Okay, so it is a design problem. So we're given a wide flange section W14 by 550, and that column is used as a column, no? And to carry an actual service loads of dead load of 1450, so service dead load, tsaka service live load of 2150. We're asked to design for the square. So pag sinabing square base plate, the dimension B would just be equal to N. The base plate rests on full area. So full area, ano sabihin ng full area? So ibig sabihin niyan, yung P sub P natin, pag kinuha natin is 0.85 FC prime A1. So full area. Tapos of a square, syempre square din yung compression block natin, yung pedestal, with a given FC prime of 21 megapascals. Then we're asked to use a 36 steel base plate, of course, knowing that its Fy is 248 megapascals, and the properties of the column were given, such as the depth and the BF. Okay. Okay, so here are the given again. So we have the service dead load, the service live load, the properties of the columns, okay, the depth and the BF. Resting on full area, that means A1 is just equal to A2, or yun nga, 0.85 FC prime, A1 lang yung P sub P natin. Fy natin is 248, and the concrete support compressive strength natin is 21 megapascals. Okay, so we're asked to solve or design for the column base plate na square, which is the B by N by the thickness T. Okay, so the solution. Okay, first we have to solve for the P sub U. Now, P sub U is the ultimate load, column load, that would come from the service dead and the service live load. So that would be 1.2 of dead plus 1.6 of live load. So that gives us 5,180. Okay. So next is since the base plate rests on full area, so that would be our P sub P, 0.85 times 21 FC prime, tas yung A1 yan yung unknown. Okay? So with the design principle of the NSCP on column base plate, considering bearing, so the resistance factor is 0.65. Okay? So that's for bearing. Then 0.65 times P sub P is 0.85 of 21 times A1. Okay, just equate it with the ultimate load, which is the 5180 times 1,000 to make it newtons, to make our equation consistent. So from there, I could come up with this area required, A1. So 446,455, so square millimeter. So yan yung kailangan nating area para hindi siya mag-fail against bearing. Okay, bearing on the pedestal. So yun yung ibig sabihin yan. That would be the minimum area. So ibig sabihin, any area above that value would be sufficient to prevent bearing stress failure on the pedestal. Okay, so using that minimum area, so just get the square root of that area to come up with the dimension of the B and the N. And the B and the N is 668.173, so you just round it up. No? So I round it up to 675. Now, sa exam natin, to make our answers uniform, so ang gagawin na lang natin is for the dimension of the B and N, so round it up to multiples of 25 millimeters para pare-pares tayo pagka nag-round up. Okay, like for this example, 668 millimeters, so di ba multiples of 25, 0, 25, 50, 75, at saka 100. Okay, so ganun yung multiples of 25. Tapos for the case of the thickness naman, pagka nag-round up tayo doon, round it up to the multiples of 5 mm naman. Okay, so para pare-parehas tayo. Pero if I ask you sa problem na give me exact values, exact calculated values for the dimensions, so be it. Wag mo i-round up. Okay? Okay. So tapos na tayo sa dimension B and N. Again, nakuha natin yung dimension B and N based from the first mode of failure, which is bearing stress failure sa pedestal. Okay, yung thickness naman, masosolve natin siya by considering the second possible failure, which is bending. No, yung dinerive nating thickness formula. So dun, that was based on bending. Okay, so for the thickness, so using the derived equation, diba, yung thickness should be greater than or equal to small l square root of 2pu 0.9 bn fy. So formula na yan, pero kailangan, gusto ko naiintindihan nyo kung paano na-derive yung formula. Again, the formula was derived based on bending, no? Bending stress. So alam naman natin na yung pu, so nasolve na natin yung pu based from the service loads. The BNN nasolve na natin from the first part due to bearing stress failure. Fy of the base plate, the depth, and the BF. Okay. So using the formula, first we have to identify yung L. Yung L is the length of the strip, and that will be the largest among M, N, tsaka N prime. Okay. Nung sinolve ko yung M, so that would be capital N minus 0.95 of D over 2. So ang ginamit kong N dito is 675, yung rounded up value na. So whenever you solve for the thickness, kailangan ang gagamitin mong dimension ng B tsaka N is yung kung ano yung decided mo na gagamitin na dimension for B and N. So if you decided to round it up, so yung rounded up values yung gagamitin mo sa pag-solve ng thickness for M and N. Okay? Pero if you don't want to round it up, yung B tsaka N, so dapat ang isa-substitute mo na B and N sa pag-compute ng M tsaka N should be hindi rounded up din. Okay? So ganun siya. So since we decided to round it up, no? So yung rounded up value yung ginamit natin na N dito, yung 675 minus 0.95 of D over 2. Yung formula na to, I want you to remember this formula based from the figure. No, so dapat na-visualize mo kung ano yung itsura doon sa figure para mas madali siya matandaan yung mga formula. So hindi to mine-memorize, no? Mas maganda na intindihan niyo kung paano to lumabas yung mga equations sa to based from the figure. So kung paano ko in-explain to on the previous video, so dapat ganun mas maganda niyo maintindihan siya para less yung pag-memorize ng formula. Okay, so we got 93.35 yung M. Then next is, how about for N? Okay, for N naman, it's B minus 0.8 of BF over 2. Again, yung capital B na ginamit ko rito, 675, yung rounded up value. So I got 162 naman for this case, 162.7 for N. Tapos yung pangatlo is yung N prime. Yung N prime, if you will remember, is based from the study of Thornton na possible magkaroon din ng bending dun sa loob ng wide flange column. Sa area sa loob ng wide flange column. Okay, so solving for N prime, so as per Thornton, it will be 1/4 square root of D times BF. So we got 118. So among these tatlong values, we have to choose yung largest. Kung sino yung pinakamalaki, yun yung gagamitin natin small letter L dun sa formula ng thickness. And we got 162. Okay? So 162. Now, so we have the L, 162. Yung PU, okay, so yun yung ultimate load coming from the dead and live. Tapos yung B, ito yung nasolve natin kanina, tsaka yung N, tsaka yung FY given naman. So we solve for the thickness, 51. So 51 would be the minimum thickness as per computation. And we rounded up, say 55, multiples of 5 lang, multiples of 5 millimeters. So we got 55 millimeter to be the thickness. Okay, so finally, our design answer would be adopting 675 mm by 675 mm by 55 mm A36 steel base plate for this problem. Okay, so that's how we design rectangular or square base plate given yung column load. Okay, so thank you.